because I have a lot of respect for the speaker before me after me, I decided to make my talk a little bit shorter. And it's really good because I had a lot of soda from the free soda fridge, so it's making me a little tired. So I want to go ahead and introduce my talk, an intelligent sketch-based education interface for learning complex, written East Asian phonetic symbols. It's a work from Sketch Recognition Lab with me and Tracy for this year's WIPTTE. And so, give a little quick overview. I may have it accelerated, but hopefully I have the opportunity to answer any questions afterwards. Quick demo. I want to go ahead and play this a little bit. This is a very preliminary work, but this one will go through the different cases. And this is a demonstration of what the interface is. It's a very simple interface, but it covers sort of the crucial components that instructors often want to see from students. Is it visually correct? Is that the correct technique? Is it visually correct? So these are things that instructors can provide, but computer interfaces in the education domain still having trouble with. And so it's an opportunity for instructors to be able to employ these interfaces in their classroom settings, and so that they can focus more on other aspects of the classroom, like culture, speaking, writing. So this is a system that helps augment that. So I'll go into more detail later in the talk. So for a language overview, I wasn't sure how many people knew Chinese, Japanese, Korean. So I know our Korean friend probably know Korean, but just to give a quick overview, map of East Asia, Chinese, Korean, Japanese, a lot of people speak it. Basically, it's true. Chinese, the different scripts, I'm just going to go through really quickly, that they use in Korean and Chinese. So they have phonetic scripts, and phonetic scripts are components in Korean it's very used exclusively. Japanese use a lot. In Chinese, certain aspects they do use in some contexts. And so three of the scripts are the most popular scripts of each of those CJ languages. Include the Hiragana script in Japanese, the June script in Chinese, used in Taiwan a lot, and also the Hong script, which is used a lot. And so, what is the motivation of doing this type of work? So, students are learning these languages in the United States. They often focus on at least 5 different so reading, writing, speaking, listening, and the culture, and going to know culture because it's very infused with the language. And so, some of the things that is important is also in phonetic symbols, which is one type of script. So, unlike English, where we use one script or one script, in other languages they use a combination of scripts at times. And so, phonetic scripts are something that's important. It's also a little bit complex. There's some challenges involved with it. So, take a student who thinks in English, very fluent English, but has no background in existing East Asian languages. For example, if the student is learning Korean, but has no background in other languages such as Japanese or Chinese, it's challenging because they don't have background to help them really use some sort of like related evidence to help them memorize those languages. And so, one of the more challenges is that there are more symbols in the phonetic scripts. So we have English, 26 letters, A, B, C, D, E, it goes up to Z. There's 4 components for Hangul. Hiragana has 48, so it's already more symbols than already in English. It's one challenge. The other challenge is the fact that it's more complex. It's kind of scary. It's English simple lines, of course, but it's much more complex in Japanese. And there's more variations. Korean's a special language, so very lots of communication. So as you can already see, compared to ABCs, it can be a little complex. So there are pedagogical writing approaches for students to better understand how to memorize and master the phonetic script. So some of the approaches include rote practice, where you write over and over again, and then also stroke technique, stroke order helping get the text through. So current resources we have here, classroom instructors, they get personal feedback, doesn't scale up too well. Textbooks, workbooks, very accessible, but output is very hard to get feedback. Educational apps, they're also accessible, but unfortunately, they have limited feedback. And then commercial handwriting tools, which are really great at understanding visual writing, but unfortunately cater more towards experts and don't provide feedback on improving the writing. So, some proposed solution is to be able to get the intelligence of a human language instructor, be able to combine the powers of machine learning techniques from computing devices, and also take advantage of computing implementability. So that's the motivation for our work. So some of the prior work, we have flashcard apps, which are really great, in the fact that they're using review, but unfortunately, you know, red writing, and you have trace maps, unfortunately, you don't get the flexibility of your writing style, so you have to make sure you follow a strict structure. Drawing apps also have it, but they don't provide feedback other than whether it's right or wrong. Merging research interfaces, they often use alternatives. This is one app for one application like Sketch, but unfortunately, it doesn't provide feedback on the technique, and the machine learning techniques usually geared towards experts, and sketch interfaces such as a ladder latch prior work unfortunately require that you have to define symbols, unlike, so in order to define a symbol you have to write out what it is, you have to specifically define, so it's time consuming. So the methodology we use in this work is, I'll go through really quick, but basically we got training data from 3 different types of users: experts, freehand stylists, novice trace stylists, and expert trace touch. And so we feel that a good training data will help give good model data, but you don't want too much data because then it slows down the system. So this is how we call it, sort of like a good model. So we use template matching, which is a common approach in machine learning. And then that involves Hofstra business. Basically, it just matches. It's very similar to what I was discussing in my episode. Then visual assessment. So let's take one type of draw on the left and which one is on the right. And so by using visual assessment, figure out which one is the best match, what colors over. And so the left one would be classified to the right, so it's more similar. And then technical assessment. Basically, we get the points, try to figure out which of the points are closest to the other points, and then we give it labels, and then we look at the timestamps of the labels. And so if the timestamps are similar, that means that strokes are in the correct order. So here's the interface. I'll go really quick. Initial interface, you get to choose between 3 different scripts. And then input interface on the left is you get the feedback. On the right is where you do the writing. And so case 1 is completely correct. So right now, it basically draws, and then you draw it really quick. And then when you do a check, it says that it's correct. Incorrect order. And this is one of the main contributions to the work, is the fact that we can be able to differentiate the technique as well. And do the check. And it says that the red indicates that that should have been the second. The incorrect direction, where basically you wrote it, the second stroke in the incorrect direction, so it highlights the point where it should have started. Correct symbol basically says that the user wrote the wrong corresponding symbol to the genetic question, and gives it that, says it's incorrect. And then this one is checks to see if it's messy. So really checking says that it doesn't fit anything that is too messy. So evaluation, we took 2 experiments from each of the languages, and either touch or stylus. What we're able to do is visual assessment, do pretty well, technical recognition with the expert users, purposely write variations of the incorrect order, and we're able to detect that it was also technical review. So initially it did pretty well. So next steps, want to improve the performance of the system, work with teachers to deploy the classroom settings, as well as release them in that market, app market, so we can be able to figure out what is the feedback we get from use in the real world. So conclusions, created intelligent sketch interface, able to provide visual technical assessment, and reasonable recognition for seeded case data. So that's all I have, and thank you for listening.
We have time for one question. Is that all right?
Yes.
So what's out there now that someone needs?
So there's a lot of apps that do a lot that they provide symbols. They usually do it for Chinese symbols, Japanese. So, but for phonetic symbols, usually they use a flashcard, or they say, here's what the symbol looks like, and you trace over it, or it's very simplified. So there's quite a number of apps, but in terms of whether the user is writing it correctly, there's been very little research because of the fact that it requires a different type of automated recognition tool. It's been something that's been an open challenge, and so we want to see if we can get this applied to the real world setting to see that this is something that teachers will be able to really take advantage of, because right now they're doing it manually on the board. That's a good question. There's a lot of work, but it's very limited.